Okay, we're looking at exercise 3H, projectile motion, the equation of the path. We're looking at question 9. A boy throws a ball with speed v at an angle of 45 degrees to the horizontal. Derive the expressions for the horizontal and vertical components of the displacement. Look, he obviously can't throw it from the ground, but you don't know how high. It might come up later in the question, how tall he is or from what height he throws it. But that's okay. We'll just take v equals 0. X is 0, y is 0 at the moment. And if we have to do some adjustments later, we can do that. All right. So initial velocities, cos of 45 degrees is x dot, that's the velocity there on v. So v is x dot cos 45, which is x times 1 on root 2, which is x on root 2, which is, to rationalize it, x root 2 on 2. Also, sine 45 is y dot on v. Y dot equals v sine 45, I'm doing it again, which is v on root 2, which is, y dot is root 2, sorry, that's a v. Sorry, what's wrong with me? X dot v, x dot v. Y dot is root 2v on 2. Sorry, girls. Okay, now the 6 equations. Horizontal. Acceleration is 0. Are we good? Have you got those, girls? All right. The velocity is the integral of 0 dt, which equals constant 1. I need to move down. So when t is 0, x dot is root 2v on 2. So therefore x dot is root 2v on 2. The displacement is the integral of that, which is root 2 on 2 vt plus c. When t equals 0, x equals 0, that gives us c equals 0. So therefore x equals root 2 vt on 2. Vertical components of the velocity. Girls, we've done this so many times. You might want to box up your equations. Vertical acceleration in the vertical direction is negative g. Velocity in the vertical direction is the integral of negative g, which is negative gt plus c. When t is 0, y dot is root 2v on 2. So we get root 2v on 2 equals 0 plus, sorry, that was constant 2. This is constant 3. Therefore, constant 3 is root 2v on 2. Therefore, y dot is negative gt plus root 2v on 2. The displacement is the integral of negative gt plus root 2v on 2 dt, which is negative gt squared on 2 plus root 2 vt on 2 plus constant 4. When t is 0, y is 0, therefore c4 will be 0 if you look at that. So therefore y equals negative gt squared on 2 plus root 2 vt on 2. So it does have a, yeah, you can put it all over 2. It is a common denominator already. Okay, next part of the question, that's the easy bit. They often don't even ask you that. Hence show that the Cartesian equation of the path of the ball is that. Do you remember? Look at that Cartesian equation and what's it missing? T. So what do you think you're going to do? And Cartesian equation of the path of the ball describes position. It's the displacement equations. We're just eliminating the t from the displacement equations. So you're working with the two displacement equations to eliminate its parametric equations, making t the subject of the displacement in the x direction and substituting that into the y equation. With this equation here, horizontal displacement. We make t the subject, so you get 2x on root 2v. Then we sub into y equals negative gt squared on 2 plus root 2v on 2t, which is, now I like to write down everything else apart from the t and then put the t in. You can square it straight away if you want. Do you want to square it? Or you want to just write it out? So we got 2x on root 2v squared plus root 2v on 2, 2x on root 2v. I hope I didn't make a mistake. Which is negative g, don't you get 4x squared? But then on, all right, we get 4x squared on, what do you get on the bottom? You got the 2 times root 2 squared is 2, v squared is v squared, plus we've got 2 root 2 vx over 2 root 2 v. Very nice. Most of it cancels, as has been told. So you get negative gx squared on v squared. The 2 root 2's cancel, so does the v, plus x. Which is, we're done. So it's x minus that. So therefore y equals, so therefore y equals x minus gx squared on v squared. Are you up to part 3? Because no one's talking, so you must be up to part 3. Girls, the boy is now standing on a hill inclined at an angle theta to the horizontal. He throws the ball at the same angle of elevation of 45 and at the same speed v. If he can throw the ball 60 meters down the hill but only 30 meters up the hill, use the result in part B to show that this result. Now, we need to draw. Standing on a hill at an angle of theta, sorry, not alpha to the horizontal. He throws the ball at the same angle of elevation of 45, the same speed. In other words, all those equations apply from what we've done. If he can throw the ball 60 meters down the hill, so when he throws, I'm assuming it's that distance is 60, that the hypotenuse is 60, and 30 meters up the hill. Use the result in part B to show the result that we're going to see. So, throw it 30 meters up the hill. It doesn't say horizontally, that is up the hill. He can throw it 30 meters up the hill. He can throw it 60 meters down the hill. It says, guys, if you're trying to throw a ball up the hill, it's not going to go as far. If you're going to throw it down the hill, it's going to go further. When he stands here and if he looks up the hill, he can throw it 30 meters. If he throws it with the same trajectory, 45-degree angle, same speed of v, he can get 30 meters up the hill. Now that is on the diagonal. If he turns around and faces down the hill and throws it the same, it will go 60 meters down the hill. That's 60. Now, girls, that's displacement. So we need right angle triangles for displacement for this one and for this one. Okay? Now I'm going to draw them on the next page. If you're sitting there saying, how do we know it's not 30 horizontally? They'll tell you if it's 30 meters horizontally. If they're saying 30 meters up the hill, that's 30 meters there. It's not upwards. 30 meters up the hill, 30 meters down the hill. Okay. I'll just pause. Theta equals this expression here. Okay? Up the hill 30. So girls, I think we're going to be doing simultaneous equations somehow. 30 degrees. This is x in the horizontal direction y. Okay. It's not x dot, y dot. That's a distance of 30. Okay? That's all we know. We also have the other one where he's throwing the ball down the hill. See how he's throwing it down here? That's 60. And we've got, because he's throwing it, the ball ends up down. Here's the hill. Wait, girls, watch. It doesn't matter. He goes up 30. Look, up 30. Can go like that. I could do it like this. It doesn't matter. Like that or like that is the same. Same. Do you want it the same way? Well, I'm doing it like that because that's the way the ball goes, but it doesn't matter. Which angle's 60? Theta, it's this one because that's the hill and that's the angle with the hill. All right, that one's okay. Doesn't matter. Use either X and Y. Okay. When the question said that he throws the ball with the same speed and at the same angle of 45 degrees, see, this has got nothing to do with the ball being thrown. This is the hill. Up here is the 45 degrees at which the ball is thrown in there. In there is the 45 degrees to the horizontal at which the ball was thrown. So, girls, these are displacement only. They're only displacement. We've been told to use the equation in part 2, which is y equals x minus g v squared, x squared on v squared. Now, we don't know what v squared, and it's in the end anyway, so we don't have to know what v squared is. Okay? Girls, look at all this. 30 cos theta, 60 cos theta. What do you think they're doing? Do you think they're doing Pythag or trig? They're doing trig. Where else are they getting cos 30 cos theta, 60 cos theta? They're doing trig. When we look at the solution, you can see that there is this like 30 cos theta, 60 cos theta. It's coming from the right angle triangles. And it's coming from obviously doing the value of x here. So they're coming up with a value of x here. I'm not sure if we need to do the y. So let's just start with the x. We're going to use that. So let's look in this triangle here. What have we got? Cos of theta is x on 30, therefore x equals 30 cos theta. Let's look in this triangle because we know there's a cos 60 cos theta here. So we go cos of theta is x on 60. So in this one, x is 60 cos theta. Now, we're going to obviously have to use both. We're going to have to probably set up some simultaneous equations. So, notice we're also trying to get a tan theta. Where are we going to get that from? Sine on cos, more than likely. So let's do sine theta as well. So sine theta is y on 30, therefore y equals 30 sine theta. And here cos of theta, you know what I mean. Because I've got a tan here in this equation. Where am I going to get tan from? Sine on cos. That's the only place it can come from. So sine theta, also with the triangle, you would do both anyway. You would do both. Girls, just doing the x component is not going to help you with that 30. It only describes one part of the story. So you do need the x and the y components. Sine theta is y on 60. Y equals 60 sine theta. So girls, we're going to use this equation. We're going to set up two equations. Substitute x and y for the first triangle in here. Substitute x and y for the second triangle in there. So now I would go sub x and y into this equation for both of them. Sub x and y into this equation. That's what I would do. I really can't see anything else to do. Okay, so what have we got? 30 sine theta equals 30 cos theta minus g 30 squared cos squared theta over v squared. First equation. You know what? Why don't we divide through by cos theta? That would be a great idea. Because if you divide through by cos theta, you get tan. So now we're going to divide through by cos theta. 30 cos theta is even better. So divide through by 30 cos theta, and then you're going to do the same thing on the other side.
Wait, we're dividing through 30 cos.
Yeah, because look, 30 sine theta, 30 cos theta, 30 squared cos squared theta. You want to get tan. Tan is sine on cos. Look, unless I do the other one, look, I think we should divide through by 30 cos theta. And if you do that, what do you get here? Tan theta. What do you get here? 1 minus 1 of the 30 cos thetas goes. Because it's squared, you get G 30 cos theta on V squared. Beautiful. Let's do... Because we were squaring, we had gx squared. So we were going x squared is 30 squared cos squared theta. So you'll do the same thing over here. Exactly the same. One sec. 60 sine theta equals, for the other side, 60 cos theta minus g, 60 squared cos squared theta over v squared. We're going to divide through by 60 cos theta, and we're going to get tan theta equals 1 minus g, 60 cos theta over v squared. Now, equation 1, equation 2. Problem, it's not exactly what we needed. If you're throwing up the hill, you're going to the right and up, aren't you? Both positive. If you're throwing down the hill, oh, the x is negative too. You're going backwards and down. Because the boy has stopped and turned around and thrown the ball, the x is in still the same direction as where the ball's being thrown, so the x component is positive. Because he's turned around and thrown it that way. It doesn't matter that he's turned around, as long as he's not, he's throwing it that way and it's going that way, so x is positive. The displacement's in the same way that the velocity's going. All right, but it is going down, so y is negative. Look, as yesterday's question, when the ball hit the wall and then it bounced back, we got a positive value for x of 25, and then we went 75 minus 25 was 50. So he's throwing it that way. Yes, it's traveling that way. So we go, the y has to be negative because it's downwards. So I'm going negative sine 60. Negative sine 60. So we're going to go as y is less than 0, the ball is going down the hill. So girls, y is negative as the ball's going down the hill, but the x is positive because he's throwing it that way and the ball's travelling that way. And when we work out x, it's that distance travelled there. So we've got negative sine 60 there, so we're going to divide through by negative cos theta. So we'll get negative tan theta, negative 1 plus. So therefore...
No, you don't get negative tan.
So therefore tan... Oh yeah, no, I had negative sign. We could swap sides. Or we either swap sides, we could swap sides or divide. You can't divide by negative. Oh, yeah, you get tan. Thank you. All right, mistake. Thank you. Yeah, divide through by negative 60 cos theta. Sorry, you just get tan. My mistake. So we get negative 1. Negative 1. You're dividing by negative cos 60 cos. Wait a sec. So therefore tan theta is G. Okay. Shh. Girls, we're done. No. Just one sec. So girls, now we have to hence show that theta is tan to the minus 1 of 1/3. You show that. You have to derive it. Don't even bother if you're going to do that. What are you going to do first? Get rid of the v squared. But there's no v in their one. I'm going to multiply through by v squared. I don't want a denominator. V squared minus 30g cos theta equals 60g cos theta minus v squared. So girls, it's been suggested to make v squared the subject, then we can eliminate it. That's probably better. See what I would get. I would get 2v squared equals, if I did, 60g cos theta minus 30g cos theta. I could probably factorize out. How's it going to help me? Cos theta. Yes, it is. It's 90g cos theta. But I don't think I can really do anything with this. I would get 2v squared on 90g is cos theta. There's no way I'm going to get tan theta. Tan theta is a third from that. That is just not going to work. Unless we've got some expression somewhere for v squared on...
Then just make an expression for v squared, but only you don't, instead of making v squared...
How our other option was to make cos theta the subject, and we were toying with that, but we decided not to. Well, it seems that that's the way to go. So girls, you had to decide. You're going to make... See, if you put the tan thetas, equate them, you end up with cos. But if you make cos theta the subject of both of them and equate, you'll get tans. So we're going to try that before we do the v squared. Because if you do the v squared, you get cos squared, the cos and the tan. So that didn't work, but that's okay, girls. This often happens with these questions. So let's make cos the subject. So what have I got? Continuing from there, tan theta,
This is an announcement for year 7.
30g cos theta over v squared equals 1 minus tan theta. So therefore, cos theta is v squared, 1 minus tan theta over 30g. Going to do the same thing over here, rearranging. We've got 60g cos theta over v squared. That equals tan theta plus 1. So therefore, cos theta is v squared bracket tan theta plus 1 over 60g. Now we're going to put these two equal to each other. Equating these two equations, cos theta equals that, cos theta equals that, we get that equals that. The v squareds cancel, and you can put the 60 up there, and maybe we'll put this, all right. So the v squareds are going to cancel if you divide by v squared, divide through by v squared over, all right, so we got 1 minus tan theta over 30g equals tan theta plus 1 over 60g. Now what are we going to do? Multiply both sides by, what do we multiply both by 60g? Multiply both through by 60g. Here, we want to get rid of these denominators. If we multiply through by 60g, you lose the denominator on the right, you end up with a 2 on the left. Let's expand. 2 minus 2 tan theta equals 1 plus tan theta. Taking the tans over to the left, tan theta, so we get 3 tan theta, 2 minus 1 is 1. We get tan theta is a third, and we're there. Therefore, theta equals tan to the minus 1 of a third. So girls, that idea of making cos, and I was a bit lazy not doing it in the first place, that was the way to go because it eliminates the cos, gives you the tan. All right? Very good. You've been scanned the other solutions, and I'll also do the last question. All right?